All right, yes. To recap, Jackson says the rate of Emma's line is increasing and Maggie's line is not increasing as much, and the word for the rate of increase or change in a line is slope. All right, so, okay, these are a couple definitions. It's the next screen. All right, proportional relationships. So today is 12-5. All right. A proportional relationship is when two quantities vary directly with one another. Pretty much that means if one item is doubling, the other one's doubling. For example, let's say, Nate, this is the definition. Let's say, are you going to write it? Let's say a kid makes $10 per 1 hour. If you were to double the hours to 2, that if it was proportional, that person will be making $20. Proportional relationships have a unit rate. That means like how much or how many for one of something. Do you think it would cool down if I put my fan on?
Maybe.
Would that bother you guys?
Find a good spot. There's no grass. Turns around. Someone steal? How does someone steal the outlet? Maybe even lost the door. That's not sanitary. That's so much probably not. One of my friends is checking the dinner. Oh, eat it. Oh, my God. Wait, what? Little plastic. Yesterday? Oh. It was yesterday. It was worse.
There's another mango now back here.
There is? Is it all moldy? Juicy? I have it. Operation Take the Mango.
There's a go.
Is yours?
Because Carter said that it, you know, it's old when, like, when you take it
Oh,
off your fingers.
My hands are just that.
No, Carter's on.
We got
Fingers, like,
I have no idea.
oh,
Oh, mine
it's
was
not.
not.
It's like 3, 7, it's like 3, 5, 7, 9, 9, 7, 5. Yeah, something like that. I don't know. It's not ladders.
Like, you know what I mean? Like, how much ladders, like, cross country, you have to do, we start with 200, 400, 600, 800, 1,000 meters, and then we go back down.
Yeah, they do. They got, well, a couple of people on Zelly
All right, sorry about that. Okay, so a unit rate. So for proportional, it has a unit rate. When you take it, it's pretty much asking how much or how many for one of something. Where do you see unit rates in everyday life? It makes things easier to understand. Alex, give me one example.
One car is going 20 miles an hour, and
Speed.
then the other one is speeding at 80.
Okay. Just this idea of speed is a unit rate. When you think of 20 miles per hour, you think, well, that's not that fast for a car. But if you think of 85 miles an hour, you're like, wow, that's really fast.
Kilometers.
It makes things easier to work with. For example, does anybody play baseball?
I do.
All right, let's go with Brandon. Brandon, would you be willing, if the game was on the line, would you be willing to get hit by a ball going 45 miles an hour?
Oh yeah.
Bases loaded, bottom of the ninth, tie game.
Kick it up to 60. That's really not
Okay, so you say yes because you understand. You go, I could get hit by a 45-mile-an-hour pitch, and it probably won't hurt that much, right? But watch this. What if the pitcher was throwing 237 miles in 3 hours? Like, wait, you're like, oh, wait, hold on. Did you see what I did? I changed the numbers. You don't really know, is that fast or is it slow? Wait. Notice what I said. I said 273 miles in 3 hours. So you see how I changed it. I didn't ask you to get hit by a 273-mile-an-hour pitch. That would probably go through you. We're trying to win a game, not have a funeral, right? So yes, speed is one. What's another example? Let's see how many of the ones you guys come up with. You don't have to write these down, but you can if you want to. Yes. Time. What do you mean by time? Because it's because it's two quantities, it's time per what? What about this? Here's a hint. Your dad probably does this a lot. What's that right there? Oh my God, that's probably not healthy.
Heart rate?
Heart rate. Beats per minute. It just had. I think mine is elevated, hopefully because I was just moving some heavy objects in the corner of my room.
Did you see that's not healthy?
103 beats per minute. Well, I was just moving stuff, and I have a sweater on, and I'm hot. Okay, I'm unhealthy. I get it. You're not my doctor. Leave me alone. You're bullying me. Yeah, heartbeats per minute is an example of unit rate. They say a normal heart rate should be between, I believe, 60 and 100. So I'm 3 above normal. What about gasoline? When you buy gas, they charge you per 1 gallon. So right now, everywhere that I drive by is $2.06 per gallon, and then I get to Get-Go up here, and it's still $2.25. And I'm like, when is it coming down? I want to use my fuel perks. Because in a way, I'm wasting 20 cents of fuel perk bonus by not waiting for it to come down, but they just keep it there for days. I don't know. It's really frustrating. When you buy lunch meat, they charge you. Oh, you want this turkey? Oh yeah, it's $6 per 1 pound.
What?
It is normal. Go over there, Giant Eagle. Go look at that turkey.
Giant Eagle's expensive.
I got turkey from Giant Eagle.
Maya.
It's $4 a pound.
What's what? Oh, I'm sorry. That should be. That's heartbeats. All right. The other one is jobs. A lot of jobs, they pay you per hour, so it's a unit rate. How much are you making? I'm making $9.25 per 1 hour. So anyway,
No, minimum wage.
I think it's more
That's
than
only
that.
for Cleveland, though.
I don't know.
It's like
All right, let's go back to what we started with. This is discussion. So the discussion is, do you think Emma's line is proportional? Again, Emma's line is the blue one. Do you think Emma's line is proportional? And then think about, is Maggie's line proportional? Let's just focus on Emma for now. Brandon?
Yeah.
Why?
Starts at 0. I just heard like a whisper in back in her head.
Because it starts at 0. Does every line that starts at 0 going to be proportional?
No.
What do you think, Allie?
It's also straight.
So it looks, that's true. In order to be proportional, it has to start at 0, 0, and be a straight line. Can we prove it? Yes. Somebody give me 2 ordered pairs on the blue line. Somebody that's probably close. That can. All right, Rebecca, you can see that far?
No.
All right, Rebecca, give me 1. Give me 1 point.
Give me 1.10. 35.
All right, let me get a.
Oh, the random one.
What you got?
Yeah, no smiling. Something like that.
No.
Can I make it smaller?
Yeah, we can.
All right, she said 10 and what?
35.
Hurry up. All right, Rebecca, I put it at 10:35. Is that a good location?
Yes.
No, it doesn't hit the blue line.
You didn't tell me that I had to be with a line.
I said on the blue line.
Oh, sorry.
Somebody help me out here. Ian,
Like 30 and 6.
30. We don't even go to 30, Ian.
No, like 30 yards.
6:30.
Okay, so 6:30. Yes. So here's a good order pair. So you guys agree it crosses there at 6:30. Now you got to be careful. If you look at it, oh, this one cross. Give me another point. Any other point that you see, Ben?
8:40.
Okay, let's see if that's right. 8 and 40. Is that good? Yes. Okay, now, just like we warmed up with the cross multiplying, let's do that. And when you set this up, it doesn't matter how you do it, as long as you're consistent. You can say 8 is to 40 as 6 is to 30, or you can say 8 is to 6 as 40 is to 30. Which one do you want to do? Do you guys want to do within order pairs, or do you want to do like a cross? Yeah. All right, so we'll go 8 is to 40. All right, 8 is to 40 as
Did you just say that Alex's musical Sure.
Shh, quiet down. Guys, just because I can't stand up there doesn't mean that when I sit down to type this stuff that you're allowed to talk amongst yourself. All right, I literally plugged in 8 is to 40 and 6 is to 30. If I cross multiply, what do I get on each way? Rebecca, do you guys agree with that? This is 240, and this is 240. So yes, you get 240 either way you go. It is, so is Emma's line proportional? The answer is yes. Is Maggie's line proportional?
No.
Oh, hold on, we heard yes and no. Give us reasons why you say yes and reasons why you say no. Let's go with Rebecca.
No, because if I just start at 0, 0.
Okay. Did anybody say yes? Is that line straight though?
Yes.
So wouldn't it still be proportional?
I thought I had to start at 0, 0.
You're right, it does. But let's show why. Ben, idea?
So an example would be, so it starts at 0 and 30. So you think the rate would go up? Wait, no. It's not proportional because you can't find the rate.
It will have a constant rate of change, but the thing is, if I set it up in a proportion, will it work? Let's find out. Now, this is a lot harder to find points. Those of you in the back of the room might think it hits at 2 and 35. Does it hit exactly at 235, or can you kind of see the cross?
34 maybe.
Low.
So it's below. We can't use that point. You want it, is it crossing good here? No. 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 Yes. No. 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 Yes. So it only crosses up here or down here perfectly.
Okay, if it tilts technically a constant rate depending on how much is in between.
It will still have a slope and a constant rate of change. Let's use something different. Let's use a little star maybe.
Run the rainbow.
Okay, that's as good as I'm going to get that. So that's one. And the other one is at what point did we say it was good? This one? All right, somebody tell me what point that first star is at so I can type it in. Let's go with Karina, yeah. All right, she says 1050. Is she right? Let's check it out. She is good, 1050. And what about the top one? All right, Brandon. 2070. Is that good? Yeah. All right. So now let's set it up. If we're going to do it consistently, is 10. Maybe I'll go in blue still. Is 10 over 50. You see how annoying this is? Changing colors. Equals. The other point is going to be 20 to 70. We're just going to give up on the blue for now. Doesn't it make it look like a fraction?
Yeah.
I think I'll get faster at this. All right. Okay, let's cross multiply. Let's go with my. What do I get when I cross multiply this way? What's that give me? $1,000. Good. And let's go with. Heard from just about everybody. Let's go with Nathan. I haven't heard from him in a while. What do I get when I cross multiply the other way? 700. All right. Is it proportional? No. 700 is not equal to 1,000. So the answer to this is no. All right. In your notes, you guys were right. It has to start at 0, 0. And it's going to increase at a steady rate. And the equation for a proportional relationship is y equals mx. I'm going to change the m because that's really the only number that you really gonna you have to change here. Like let's make it a red m or green or brown, whatever that is. Whatever your slope is your m. Whatever your rate of change is, that's your m. Yeah, thank you. Did your brother clean his fish tank yet? So he still leaves it dirty in there?
No, I'm gonna throw it out.
The fish tank? They're like, this isn't even worth saving.
Oh, terrible.
Did you guys do it yourself or did you hire a hazmat team? Should have saw this fish tank.
No, I
You
had
have a
a
word problem on it.
Oh, did I?
Yeah.
Yeah, I heard it.
Cool.
What? That's a great question. Why do you think we use y and x? What's the possible reasons? Yeah, Karina? Alright, for one, the y-axis and the x-axis is, that's why that's y and x. And then the m stands for your slope. The next slide will be on slope. Okay? And we'll go slow, Alex. I'll give you examples of this stuff later. Because I told myself to record 7th period, which I'm doing. Because kids that are in 4th period, they were finishing up their tests and they didn't get the notes, so I told them I would record it. Am I good? Hopefully it lets me upload it. Sometimes it doesn't. Not yet, you said. I could stop if I want to. I'm not done yet. All right, slope. All right, slope measures the steepness of a line, which is what I believe Jackson was talking about. It describes the change in y to the change of x. So later on this year, we're going to be doing a lot of stuff with like graphing linear equations and slope. You're going to hear me say rise over run. How is it rising and running? Yes, Ben.
So, which focus area would this go with? Because the next one, after expressions and equations.
I think there's one called linear relationships.
Here's one.
And I think this.
So I think I might be working on this one.
If one of the vocab words is slope,
I think it might be.
is it an 8th grade one or 7th grade?
It's 7th grade, it's 4th. No, actually, never mind.
I have to see it.
I can open my computer and show you what it is. I'll show you. Let's see if it's. I don't have to, because I sometimes go out of order, so I can't see.
Is that
Are mangoes expensive?
I think they are.
Sell on the black market.
Proportional, would it work for proportional relationships? That's still working.
Okay, let's look at
Wait.
Yes, thank you, Brett. Oh, it's not
You didn't twice? We looked up
So
the
it not
fake,
I don't know. But this, some of the notes you did take, yes, this idea of slope doesn't go with it, but these notes do. For
So this could work as
as
evidence?
proportion, yes. This
That's all,
does.
that's
Okay, I'm sorry. I was thinking about
You
slope.
looked up a fake one on
Alright, just so you know, here's a little hint. If you're not sure what slope means, as long as you remember rise over run, listen to it. Ys over the run. Ys on top. X is on bottom. That's how I got through school, little life hacks like that. I mean,
look up the
Brandon, before I move on, do you have or I'm sorry, Alex, what's your question? Yes. Okay. What we're going back to this. What is the slope of Emma's line? Give me. What points did we mark last time?
8 over 8, 40, and 630.
Stop looking up the price of mangoes. You don't need that right now.
Can I use the bathroom?
No.
You should eat it.
We have somebody in the other room.
Oh, yeah.
Not during notes. I don't want anybody else leaving right now. This is important. Stop messing around. I'm sorry, Ben. What point did you say?
840 and 630 for the blue.
840 and 630. Do you guys agree with that? Okay, watch this. So this is your Y. Jackson, stop throwing your pencil and look up here. That's your Y. And then this is your change in X. How much is this going up? Brandon.
Like 10.
A lot of kids will say 10 or they say 2. Where do they get 2 from? Yes.
There's 2 line things.
They'll say 2 here, but it's not. You got to look at your intervals. Each of these boxes are representing 5. So it's rising 10 going over 2, not one box, but each of these is an interval of 2. So here's how you write this. You say M equals 10 over 2. What do you think that would be if it's 10 over 2? 5. The slope is 5. Let's go with this one. Maggie's line.
That one we did the ones that were actually proportional on a line.
Ugh. All right, we put a point here, and the other point is here. Actually, let's go back to the blue. Let's say you didn't move. Let's say I didn't use this blue point. Everybody see this? Let's say I was to use this point down here. Would I get the same slope?
Yeah.
Why? How much is it rising now? Let's count. It's going up 5, 10, 15, 20, 25, 30, 35, 40. And how much is it going over? 2, 4, 6, 8. Is 40 over 8 the same thing as 10 over 2?
Yep. So the slope would be 5.
So it doesn't matter what points you use when you're finding your slope. It will give you the same slope.
Wait, or is it?
No, even this line
Oh,
that's
really?
not proportional has a slope. It doesn't
Is it
matter.
the same?
It doesn't matter what point you use. Yes, you could use this point, or this point. And you get the same
So
slope.
even if the line's not proportional at all,
It
can
has a
still-
slope. Yeah. Here's the thing. The difference between 7th grade and 8th grade math is in 7th grade when they give the state assessment, every question, half the test is going to be on questions about this blue line. It's going to ask, is it proportional? What's your constant of proportionality or your rate of change? They're going to ask questions. They're probably going to give you a graph you got to put points on. They're going to ask you questions. In 8th grade, it doesn't start at 0, 0. They're going to ask you lines that start above 0 or below 0. They're going to say, what's the equation? This and that. You are never taking, most of you will not take this 8th grade test. You're going to go straight from this to algebra. But that's the difference between 7th grade math and 8th grade math with those 2 lines. Maggie's slope. Once you take a second, use your whiteboards and try to find out what do you think Maggie's slope is. Raise it, hold it up, and I'll say yes or no. Yeah. Good. Good. What is the slope? I just want one number. A slope is going to be one number. Good. No. Yes. All right. So if you haven't showed it to me, it's probably because you're not sure what to look for. Adam, that's right. That's good. All right. If I had the whiteboard or smartboard working, I'd have somebody come up here and highlight. We'll just do this instead. Ben, Gordon, I'm going to draw this, and you tell me when to stop. I want to know how much we're rising on our y-intercept. You ready? Stop, right down here. And then tell me when to stop this way. Right there? All right, you guys agree with that? Pretty good. Maybe a little late, but give me a little haircut. Whatever. Let me give it back. All right, how much is it rising? It's going up. Let's go with Ian. How much is it rising? 4 boxes. But how much is each box? So how much is it rising to go from 50 to 70? 20. So it's going up 20. It's rising 20. And then how much is it running? Let's go with Karina. What'd you say? 10. So it's rising 20, it's running 10. So the answer I'm looking for was 2. Tell me true or false. Maggie is running half the speed of Emma. What do you think, Nick? False. What would half the speed be? Yeah. They're running 5 yards per second, and Maggie's running 2 yards per second. She might only have one leg. I don't know. Wasn't there a witness's race?
Wait, really?
I just know.
If you get the middle school track,
That's right.
it's 3 o'clock.
There was this one kid I used to teach. His name was Corey. He was kind of like misbehaved a lot. Like
Wait, what year?
on like a whole spectrum of kids I've taught over the course of 10 years. He definitely is like the top 5 most headaches given to me. It was at a different school. I'll be recording it, so I'm not going to say his last name. Anyway. This was like when I first started teaching. It was literally like my second or third year teaching. And I remember the one time he was like, race me then.
Wait, to you?
Yeah.
Oh my
And I had dress shoes on, and I had he was in 7th grade.
Oh my.
Because I'd always tell him, like, you're not that fast.
No.
He's like, race me then. And like one day it was at the end of the year, and I'm like, let's go.
Oh.
And we lined up, and we raced across the parking lot. Destroyed him.
Wait, really? You did?
I'm telling you, I didn't quit.
Wait, were you in your dress pants and stuff?
Dress pants and shoes, and he had some sneakers on. In fact, he's like, give me a head start, let's do it again. And I caught him like the last 5 yards before. He was like, oh. And he was good the rest of the year. I should have raced him on the second day of school. Yeah. Yes, hurry up. All right, let's move on. Okay. What I want you to do on your whiteboards, I want you to write yes or no. Is this a proportional relationship? And then if after you find that, I want you to tell me the slope. Good. First one. Good. Good. Now try to find the slope.
Wait, can it be
Good.
random where you find how you?
No, this line has a slope.
No, I mean, can it be random like points you use or no?
It can be any points. Good. Now find the slope.
Okay.
Good job.
We estimate.
Is it yes or no proportional? I want to see that yes or no on top. Good. I check. Yes. Isn't your dad a math teacher too, though?
Yeah.
So I guess in a way, she'd probably be the second best one. Yes. Allie's dad's a math teacher. Good, good. No. The top one. Your slope.
Oh.
If you're not sure, set up. Give me a couple of
Oh
points.
wait, the slope. Oh, the slope is wrong or the.
No, your slope is right. Is it proportional?
Oh.
Good. All right, let's talk about it. That's right. Let's go with Abby. I haven't heard from Abby. Abby, do you think this is proportional?
Yeah.
It is. And why is it proportional?
What?
Why'd you say yes? You don't know? Where's it start at?
0.
On the y-intercept, it starts at 0, 0. And does it go in a straight line? Yes. And if you want to check, you can set up a proportion at any point. Here's a circle. I'm going to slide this down. Abby, tell me when to stop at a good point.
Oh, wait. Stop.
Okay, there's one. Here, I'll get another one. I'll start at the top. Tell me when to stop at a good point.
Stop.
All right, those are good points. What are these points? It's 2, 6, and 4, 12. If I was to set that up, to save time, I wonder if I could just draw this. Is 2 over 6 going to equal 4 over 12? Yeah, so it is proportional. All right, somebody else. Let's go with Rebecca. Rebecca, what is the slope you got?
I was slope
3. If you're rising 6 over 2. 6 over 2 equals 3. Now, let's take it one step further. Now that I know the slope, what would the equation be? Well, Nick was asking the equation. The equation would be y equals mx is the equation. So you just have to plug in the slope. What did we say the slope was? 3. Y equals 3x. Question? No. We're switching classes. If I put this into Desmos, every point would be on here.
Wait.
Yeah. You know what I learned yesterday? I could actually put Desmos into my thing. Watch this. I go to Insert, go down to Internet Browser. Huh?
I mean, are we doing Desmos?
Well, that did not work. Let's try it the other way. Who is that? All right, here's Desmos. What are some points that were on that line? Is it Is it 1, 3? Give me another point that was on that line. Would it be 2, 6? See, 2, 6 is right here. 1, 3. 3, 9. That's why this equation works. 3, 9. I would zoom out a little bit. There it is. All right. And notice the equation. Try this one. Oh, I can't even have you come up and write it. I want. How about this? Somebody that would have volunteered right on the whiteboard, come up with a point to where they think any spot would be that a line would hit for this pizza problem. So a pizza costs $10 for a plain and $2 per topping. All right, Brandon, point to 1 point, and I will put a dot there. Hold on, I'm not there yet. All right, where do you think this is going to hit at? Right here?
Yes.
Point to another spot that you think it might hit. Here? No, it's got to be on the grid, man. Somebody, just point to somewhere. Here? Here? All right, let's check it. Let's make this line. This is Brandon's Pizza Shop. Does that line make sense for this pizza costing $10 for a plain and $2 for topping? Why? What's wrong with this? How much does this pizza cost? So $4 for a plain, and you get 2 toppings, and it would be $10. So does that mean the slope is 3? So not quite working. Somebody think they have a... Do you know what? I've seen kids. Somebody think they have another one? All right, Colin. All right, point somewhere and I'll move it. Wait, right here?
Yeah.
And then what's another point? Right here? All right, let's make a line and see what this looks like. All right, it's kind of close to what he's talking about. Maybe I got to adjust it a little bit. All right, so does this fit that pizza?
Yeah.
I mean, how much would a plain pizza cost? $3, maybe a little over 3. Not working
I
still.
know.
Third idea. Ben?
Does it have to be like that problem, or can it be?
Yeah, it has to be this pizza shop's cost. Like a graph display how much they charge per pizza.
Be 10, 0 for a plain start.
Give me one more point.
And it'll be 20 for 20. No, it wouldn't be. It would be 12 for one.
Like this?
Yeah, like that, and then we keep.
All right. Do you guys think this makes sense? Notice what he did. He looked for 0. He says a plain pizza with 0 toppings. Do you still have to pay $10 for the pizza? and each topping is going up $2 per pizza. Don't leave yet. Wait. What would the slope be? Yeah.
It would be one. Yeah.
It's going up
Oh,
2 over 1. 2. All right. We'll pick up talking more about this and maybe doing some pods next semester.
I get 4 for the So,
I will upload it.
to be
Yeah.
clear, you can accept these notes.
4 proportions. Yes.
So I'm gonna take that next class, so I can't with you.
All right.
You also.
Thank you.